BMTC-132 Differential Equations. Block 1 Functions of 2 or 3 variables. Unit 1 R square and R cube. Unit 2 Limit and Continuity. Unit 3 First order partial derivatives and differentiability. Unit 4 Higher order partial derivatives. Unit 5 Chain rule and homogeneous functions. Miscellaneous examples and exercises. Differential equations. Since the time of Isaac Newton 1642 to 1727, differential equations have been of fundamental importance in the application of mathematics to the physical sciences. Differential equations serve as mathematical models for many exciting real-world problems, not only in science and technology, but also in such diverse fields as economics, social sciences, physiology, psychology, demography, etc. Rapid growth in the theory of differential equations and its applications to almost every branch of knowledge appears at an increasing rate, leading to a continued interest in the study by students in many disciplines. We are offering this course of differential equations to the students entering the Bachelor Degree program of UGC CBCS as a core subject. It was Isaac Newton, the English mathematician, and Gottfried Wilhelm Leibniz 1646 to 1716, the German mathematician who gave birth to the subject of differential equations in 1675. Leibniz formed a powerful tool of the integral sign, and Newton classified differential equation of the first order. A large number of great mathematicians of the past 3 centuries, such as Fermat, Newton, the Bernoullis, Euler, Lagrange, Chaput, Laplace, Gauss, Abel, Hamilton, Liouville, Riemann, Poincare, and others, developed this subject and brought it to the present status. In this course on differential equations, we shall be dealing with both ordinary as well as partial differential equations. For a better understanding of the concept in the course, a good knowledge of calculus is essential. The knowledge of our calculus course BMTC 131 will more or less fulfill this requirement, since BMTC 131 only deals with a function of one variable. To fill up the gaps, we have added contents on functions of 2 and more variables in this course. Accordingly, we have divided the materials in this course into 4 blocks. Block 1 deals with functions of 2 or 3 real variables. In this block, we are going to introduce you to the concept of limit, continuity, and differentiability of functions of more than one variable. You may recall that when you studied the same concept for functions of one variable, you had made use of knowledge of the algebraic and topological structure of R, the set of real numbers. We had used various properties of real numbers, the distance between two real numbers, and so on. So, to study this concept for function of two variables, we need to know the structure of R square, the sets of points in a plane. If we want to study functions of three variables, we need to know the structure of R cube, the set of points in space. We shall start with a brief discussion about this structure and discuss some algebraic and topological properties of R square and R cube. We shall then acquaint you with function of more than one variable. The second unit introduces the concept of limit and continuity for these functions. The remaining 3 units in these blocks are devoted to the discussions of different types of derivatives for functions of several variables, though in these blocks we shall be dealing with real valued functions of three variables. The discussion can be easily extended to functions of any number of variables. Block 2 and 3 are devoted to the ordinary differential equations ODEs, and Block 4 deals with the total and partial differential equations PDEs. In block 2, we have started with the essential and the basic definition related to the study of differential equations. We have stated the conditions on the nature of solutions and conditions under which a unique solution of first order differential equation exists. There we have discussed various methods of solving first order first degree equations, methods of finding solution of equations with degree greater than 1 are also discussed for certain particular form of the first order ODE. We have also formulated in this block some of the problems of physical and engineering interest in terms of first order linear differential equations. Block 3 deals with ordinary differential equations of second and higher order. We have classified general linear differential equations into those with constant coefficients and those with variable coefficient, and further classified these equations into homogeneous and non-homogeneous equations. The methods of solving homogeneous linear differential equations with constant coefficient have been discussed in this block. In the case of non-homogeneous equation with constant coefficient, the method of undetermined coefficients and the method of differential operators are given for finding particular integrals of the equations. The method of variations of parameters and the method of reduction of order, which can be applied for solving linear differential equations with constant as well as variable coefficients, are also given here. We have laid specific stress on the application of second order ordinary differential equations in this block. In block 4, which is the last block of this course, we move our focus to simultaneous total and partial differential equations of the first order. The method of solving simultaneous differential equations and some of their applications such as orthogonal trajectories of the system of curves on a given surface, particle motions in space, and electric circuit are discussed. Integrability conditions for the total differential equations in three variables and the methods of solving it have been given. We have classified the first order PDEs into linear, semi-linear, quasi-linear, non-linear PDEs. Classified the first order PDEs into linear, semi-linear, quasi-linear and non-linear PDEs, and gives us various types of solution and integrals of these PDEs, giving the relation between these different integrals. The Lagrange method of solving linear PDEs of the first order and the Charpit's method of solving non-linear PDEs of the first order have also been discussed in this block. Each block consists of 4 or 5 units. Every unit has plenty of examples and exercises interspersed with the text. These examples will aid you to understand the theory, and exercises are meant to help you check your progress. To master the various techniques presented in this course, we advise you to put in a lot of practice and attempt all the exercises. The solution or answer to the exercises in a unit are given at the end of the unit. We suggest that you look at them only after attempting the exercises. Miscellaneous exercises are given at the end of each block. These exercises will help you check your overall understanding of the various concepts you have learned in that block. Each problem would require you to think and decide the method or technique to be used for solving it. We are giving a list of various symbols and notations used in the text for your reference. As a part of continuous assessment, there will be one assignment based on the entire course carrying a weightage of 30%. The assignment will be available for download from the UGD website. We may like to look up some more books on the subject and try to solve some exercises given in them. This will help you get a better grasp of the techniques discussed in this course. We are giving you a list of titles which will be available in your study center for reference purposes. Some useful books: One Calculus by J.B. Thomas or R.L. Finney, Pearson Education. To a textbook of differential equations by N.M. Kapoor, Pitambar Book Depot. Through differential equations to the application, historical notes by George F. Summers, Tata McGraw-Hill. Elements of partial differential equations by Iron and Sneddon, McGraw-Hill Book Company.